All right, I'm so sorry. I had to go drop the link on the group chat. So welcome, guys. Welcome, guys. Welcome. So please, if you can hear me, my mic is off for today. If you can hear me, just drop a message. Can you hear me? If you can hear me, please respond. Just drop a message. Can you hear me? Okay. Please, is it echoing or it's just okay? Is it echoing or it's okay? Is my voice echoing or it's okay? All right, thank you. So sorry, I was sleeping. My head is scattered. I woke up very late. All right, so I will be sharing my screen. Yesterday we actually started up, but unfortunately, they took light. My network went bad. So we're just going to continue from where we stopped yesterday. I'll just do a recap on quantum numbers. All right. So we're going to be looking at quantum number today, quantum numbers. All right. So let me quickly share my screen. All right. I've shared my screen. So I am going to be using my phone to be monitoring your comment section. All right. So in case you want to ask a question, please drop your question on the comment. All right. I'll be using my phone to check it. So anytime you see me look down, it's obviously my phone I'm looking at, because once I share the screen, I'll actually move on to my board where I'll be writing and be explaining stuff. So most likely I won't be seeing your chat. So I'll be using my phone here to actually do that. All right, so let's get to it. Let's get to it. So we have here on my board. Yesterday we discussed quantum number. Please, if you have a colleague of yours that is meant to be here, I'll just inform them the class is going to be today. All right, so today we want to talk about quantum numbers. Right, I'm very sure heard of quantum number. Let me not assume everybody, but majority of us must have heard of quantum numbers, right? But the interesting part is that not just everybody understood it back then in secondary school. So whether you're writing jam or whether you're in school already, right, you actually need a proper understanding of what quantum number is. So what is quantum numbers? Even if they won't ask you in exams to define what quantum number is, obviously, it's basically a property that is used to describe an atom. Sorry, that is used to describe an electrons in an atom, properties of electrons in an atom. All right. So nobody's going to ask what quantum number is. Nope. It's just something you need to know how it's been applied. So if somebody to ask property that is used to describe or something that is on the, and we have four types of quantum numbers. We really need to understand what these guys are all about. So today, I'm just going to explain it as if um, many of us did not attend yesterday's class. But for the first part, I would be a bit fast because I already did the explanation yesterday. So you can see we have four types of quantum numbers. We have four types of quantum numbers. Now we have the first one, which is a principal. The second one, which is azimuthal. Please, azimuthal is also known as subsidiary. Azimuthal is also known as subsidiary quantum number. We have the third one, magnetic. We have the fourth one, spin. All right. So we're going to be taking these guys one after the other. What do we really need to know about this? Please, when I'm done with these quantum numbers, I'll be telling you various ways question can be asked in exams, which is very, very important. So without wasting much time, without wasting much time, let's get to it. So let's erase this part. Principal quantum number. Number one. Now, please, principal quantum number has a symbol of n. Now, what is a symbol? What does this symbol really signify, or what does it stand for? Please, are you seeing my board very well? Are you seeing my board very well? Someone said, "So you're not seeing my face." Please, for today, my light is off, right? I'm so sorry. Just like I told you, I woke up from sleep and then I just had to come up to here. So my light is it's going to take me some time to set up. So I'll just leave the lights. Please, I'm seeing no on the section. What is the no for? Are you not seeing my face? Like, are you not seeing me? What's the no for? Or you're not seeing the board? Which of them? Please, I'm waiting for your feedback. I'm looking at my phone. It's Emmanuel and Princess. You said no. Please, what is the no for? Are you not seeing the board or you're not seeing me? Which of them? No, now screen cannot be blank. The screen is not blank. Look at it clearly. The screen is not blank. Who else can see my writing on the board? Hello. We have a lot of complaint this night. I can see it. Not seeing the board very well. Anyways, I don't really know if I should still fix my board or I should just continue with the class. And continue with the class. I'll try and write. Okay, I'll try and write it properly. Now, please just I have a recorded version for this. If you just understand this, you can watch the recorded version, and of course, it will help you understand it better. Now, principal quantum number, very simple. Quantum number that describes the shell of an atom. Principal quantum number, it's a quantum number that describes the shell of an atom. Now, what are shells of atoms? Now, let me tell you something. If you could recall, in secondary school, they taught us the shells to be K, L, M, and N. Now, this is shell number one. This is shell number two. This is shell number three. This is shell number four. in the university, nobody's going to come ask you KLMN. Nope. So very simple. This 1, 2, 3 is what we refer to as the principal quantum number. So somebody asks you, what is the purpose, what is the application, or what is the usefulness of principal quantum number? Very simple. It's the quantum number that describes the shell of an atom. Now, what do we mean by shell of an atom? Let me show us this. Right? Now let's assume this is an atom. This is a nucleus of an atom. Now this is the first shell. This is the second shell. This is the third shell. This is the fourth shell. All right, so someone says to detect and write. Okay, I'm still going to detect principal. And we have the third one, N. We have the fourth one. Now, this first shell is what we call the N equals to 1. The N equals to 1 is the K shell. The N equals to 2 is the S shell. And the N equals to 3 is the M shell. The N equals is the N shell. So this K, this L, this M, and this N is basically the shell of an atom. So principal quantum number describes that. So if N, remember, this is a designation that we use to designate principal. If N is equals to 1, we are referring to the first shell, which is the K. If N is equals to 2, we're referring to the second shell. If N equals to 3, we're referring to the fourth shell. So basically, in exams, please take note that N can never be 0, and N can never be a decimal. N can never be a fraction. Take note of this. Okay? So let's get a new board. So somebody says, so please put down. Let me detect. Principal quantum number. Principal quantum number is the quantum number that describes the shell of an atom. Principal quantum number is the quantum number that describes the shell of an atom. Of an atom. Quantum number that is also known as energy level. Shell is also known as energy level. All right. And principal quantum number N varies from 1, 2, 3, 4, 5, all positive integers. Now, N can never be 0. N cross simply means not equals to. N can never be 0. N can never be fraction or decimal. N can only be a whole number. All right, so that is that for principal quantum number. Now let's quickly look at the second type of quantum number. Let's quickly look at the second type of quantum number. The second type of quantum number is azimuthal or subsidiary. Please, this has a symbol of L. Azimuthal or subsidiary quantum number It has a symbol of L. Now let me define what this guy stands for. Someone said I should be defining and also writing. Please put down. Azimuthal quantum number describes the types of orbitals present in an atom. Azimuthal describes the types of orbitals present in an atom. If you could remember, just take your mind back. When we talk about orbitals, we're talking about the s orbital, the p orbital, the d orbital, and the f orbital. Now, this azimuthal does not only describe the types of orbital present in an atom, it also describes the shape. It also describes, just 1 minute, somebody is saying something here. To read what somebody was texting me. Azimuthal also described the shape. Yes, it described the shape of an orbital. If you could remember, they said the shape of s orbital is spherical, and this guy is double dumbbell. Now, the shape of S has not really been coined. It's above this level. So, what is the purpose of azimuthal? If somebody should ask you, azimuthal, please note, azimuthal has three types of. It has two other names. You can either call it azimuthal or subsidiary or angular momentum. So let me clean it off. You can call it. Take note of this in exam because they might ask you. Azimuthal is also known as subsidiary, is also known as angular momentum quantum numbers. So let's dive into this. Let's see how we can use this azimuthal to answer questions. Please take note that azimuthal describes orbitals, and I've given us the what orbital stands for. S, anytime you see S as per 1s2, used to see S whenever you're writing electronic configuration 2p6. All these S, these letters are all azimuthal quantum numbers. So I'm going to show us how we derived or how we got those letters. So take note, s orbital, p orbital, d orbital, coined by Azimuthal. He was the one that came up with all those letters. So let's see how he did that. All right. Now let's complete the definition of Azimuthal. Please note, Azimuthal depends on principal. Azimuthal quantum number depends on principal quantum number. Azimuthal quantum number depends on principal. Principal was the first one we described. We said principal. I never mentioned anything about dependence or independence. Principal is the first one, so it's independent of anybody. Now, the second one will always depend on the first. That's how it looks like. That's how it works. So azimuthal depends on principal. Now, what do I mean? What this statement simply means is that for you to get azimuthal, you must have principal. That is it. So principal is more like the house, and the azimuthal is more like the rooms. Without the main house, you cannot have the room. Remember, these quantum numbers, they are basically describing or telling us how light in an atom, right? So take note of that. It describes how electron is residing in an atom. So let's take an electron as human beings. Human beings lives in a house, right? Inside that house, we have rooms. Inside the rooms, we have beds where you lie on top. So this is exactly what I'm trying to explain here. Principal, it's more like the house overall. Azimuthal is the room. So azimuthal depends on the house. Without the house, there won't be any room. So let's proceed. Now, azimuthal, which is L, varies from 0 to n minus 1. Azimuthal, which is L, remember azimuthal has a symbol of L. It varies from 0 to n minus 1. What does it mean? The value of azimuthal must always start from 0, right? And where is it going to n? N minus 1. What is n? This n is principal. So that's what I told us earlier. Azimuthal depends on principal. So this guy starts from 0 and ends at n minus 1. Let me give you an example so that you understand what I mean perfectly. So let's say if n if n is equals to 3, what can be the possible values of L? Look up. The possible I said possible values of L. That means all the values that are possible. Now, recall that L varies from 0 to n minus 1. So in this case now, our n here is 3. So the value of L will start from 0, which is where it starts from. N in this case is 3. So where is this L going to stop at? 3 minus 1. All right, so let's say 0 and 3 minus 1. It's going to start at 0 and stop at 3 minus 1. 3 minus 1 is 2. 0, 1. Why did I put 1 here? Any value that, any whole number that comes between 0 and 1, I must include it. It's a must. Because they did not say it starts from 0. It did not say it's 0 and n minus 1. They said it starts from 0 and ends at minus 1. That means anything between the 0 and n minus 1, you have to account for it. So if this L is equals to 0, which is where it's starting from, and n minus 1, n in this case is 3. 3 minus 1 is 2. I put 2 here. It will start at 0 and stop at 2. Between 0 and 2, what do we have? 1. So guys, what this thing simply means is that if n is equals to 3, L will have 0, 2. Yeah, I will take the explanation again. I'll take it again. I said, don't worry, let me just clean off everything here. What I'm trying to say in essence is that, right, azimuthal, which has a value of L, depends on n, which is principal. What does it mean? I like to use something different from chemistry to explain chemistry so that it sticks to our head. At the start of this class, I said the concept behind quantum numbers. It's basically what is used to explain how electrons are residing in an atom. I said, assume that human beings are electrons. Where does human being reside in a house? Obviously, inside the house, we have rooms. Inside the rooms, we have beds. So before you get to the bed, you must walk into the room. Before you walk into the room, you must enter the house. The principal is the building, which is the house itself. Azimuthal is a room. So azimuthal will always depend on principal. If there is no value for principal, there won't be any value for azimuthal. That's basically what I mean. So why do we say it is dependent on n? They gave us a formula for L. The formula for L is 0. It will always start from 0 and stop at n minus 1. It will always start from 0 and stop at n minus 1. All right, now let me give us a typical example. So if n is equals to 4, if n is equals to 4, imagine in exams you're being asked, give the possible values of L. What is L? What are the possible values of L when n is equals to 4? How do we solve that? Very simple. You say, okay, L will always start from 0 according to this formula, and this guy would continue until n minus 1. What is n in this case? 4. All right, so n minus 1 would be, in this case, n is 4. 4 minus 1, which is equals to 3. So the value of L would be 0 and move to 1 and get to 2, and we'll stop at 3 because 3 is the value for n minus 1. N in this case is 4. 4 minus 1 is 3. So that is how we're going to get the value for L. Now, what if n is equals to, we'll say, if n is equals to 3, L would be 0, 1, and 2. Why? Because 1 is 2. So if it starts from 0, it will end at 2. What is between 0 and 2? 1. Give us something to do for me before I proceed to the next guy. Please, it's a recorded version, so if you don't understand, you can always replay back so that you grab it very well. So please, I will expect us to type the answer in the chat box. Example. Give give the possible values of L when n is equals to 5. Give the possible values of L when n is equals to 5. Please, I expect us to just tell me the values on the chart, right? To be very sure we are following. Give the possible values of L is azimuthal when n is equals to 5. Let me see how many of us understood this particular explanation. All right, I'm so impressed. Jacinta said, "Sir, please explain." You know it's a recorded version, right? So if you don't really understand a particular part, or maybe miss it, perhaps you can just repeat. All right. If you still don't understand after replaying it again, please drop a message on my WhatsApp. I'll actually do that. Or you can just type it again on the chat box. If the class is still on, I'll do it. All right. So that, if I actually explain again, I'll be taking a lot other people's time and data. All right. So that's why I'm seeing the answers in the chat box. 0, 1, 2, 3, 4. Please, that is very correct. Now let's get to this. Let's solve. Solution. Remember that the value of L will always start from 0 and will move and stop at n minus 1. Now, whatever value, whatever value they give us to be n, you're going to insert it here. So in this case, n is equal to 5. So this guy will start from 0, will stop at 5 minus 1. So this is going to be 5 minus 1 is 4. Now, between 0 and 4, be in the middle. Avoid fractions, avoid decimal. You are looking at whole numbers, whole positive numbers. So between 0 and 4, we have 1, we have 2, and we have 3. So that is the answer for L when n is equals to 5. It's very simple. Now, what if you are asked to give the value of L, or if you're asked to give the value of L when n is equals to 8? Of course, they will not ask you for n equals to 8 because no atom has 8 shells for now, right? Periodic table has 7 periods. Remember, this n is a number of shells. And the number of shells, the maximum number of cells so far, can be obtained by the number of periods we have in the periodic table. The periodic table has 7 periods. Element in period 1 has 1 shell. Element in period 2 has 2 shells. But I just gave us 8 to actually test run what you've learned so far. So imagine you're asked to give the value of L when n is equals to 8. It's very simple. L will start from 0 and ends at n minus 1, which is 7. Now, remember, this n in here is 8. So if you subtract 8 from 1, you're going to get 7, 2, 3, 4, 5, 6, and 7. So this will be the value of L when n is equals to 8. All right, so let's proceed. All right, so since we've understood that part, now let's look at another critical part of azimuthal quantum number. A lot of persons are unable to attend the class. I wish I can share data for you guys. But that's just the sacrifice you have to pay. Trust me, you're going to learn a lot from this online class. We just started yesterday, with time, we'll get better, right? My pen is fainty, like it's faint, it's not bold. So I'll try and get a pen that is bold enough so that in very well. So just pardon me for today. Now let me explain something to us. When I started this azimuthal quantum number, I told us that azimuthal, right, describes the types of orbitals present in an atom. I repeat, I told us that azimuthal is a type of quantum number that describes the types of orbitals that are present in an atom. Yes, I said that. And I went ahead to tell us to refresh our memories that the types of orbital we have are the s, p, d, and f. Now, these were discovered by Azimuthal. The big question is, how did Azimuthal do that? Now, let me tell you something. So, Azimuthal actually designated a letter according to the numbers. Now, when L is equals to 0, Azimuthal called that guy S. When L is equals to 1, Azimuthal called it P. When L is equals to 2, Azimuthal called it D. When L is equals to 3, Azimuthal called it F. When this is equals to 4, Azimuthal called it G. Now, these are basically the letters that Azimuthal used to designate these numbers. Remember, it is called quantum numbers. So obviously we are expecting numbers, but in his wisdom, or perhaps after much research, Azimuthal said, okay, in 0, 0, let's convert 0 to orbital and call it s orbital. Now for 1, he converted it to p orbital. So these letters you're seeing here is what we later know as the s orbital, and these two became a d orbital, here became the f. So in case you've seen something like this is basically what Azimuthal did. All right, this is what I'm going to clean this off and write it out very, very well. Okay, azimuthal is what we use to determine the types of orbitals that are present in a compound, in an atom rather, right? Now, if you have, let's say for example, n equals to, let me show something. If you have n equals to 4 or n equals to 4, yeah? If I want to know the number of orbitals present in this shell, remember shell is actually the energy level. If I want to know the types of orbitals present in this shell, remember shell is basically more like the house. Now, so if I want to know the orbital that are present here, I will come to azimuthal. If n equals to 4, azimuthal is 0, 1, 2, and 3. So azimuthal now said 0, let's call 0 S. 1, we call it P. 2, we call it D. 3, we call it F. So therefore, energy level 4 has 4s. It will have p orbital, it will have d orbital, it will have f orbital. So it means that 4 is going to have 4s, 4p, 4d, and 4. Simply means that azimuthal helped us to know the types of orbital present in that shell number 4. Okay, I believe that is better now. Don't worry, I'm not rushing. I just want to take time to explain. No, please, for the G, you just have to ignore the G. The G is above your level, right? In secondary school, you never heard of G. So G, they don't really talk about it even in the university or even in JAM. So everything stops at F. All right, so let's write this properly. Don't worry, we are finishing up all the explanation to pertaining to azimuth quantum number, and then we are done with quantum numbers. Please look up. Now this is azimuthal. This is orbital. Don't worry, I will explain that. Someone said I'm always getting confused with it. So I'm going to explain that. Don't worry, we are not in a haste. I'm going to break it down. So let's say azimuthal, which is L. If this guy has a value of 0, the orbital will be S. If this guy has a value of 1, the orbital is P. If this guy has a value of 2, the orbital is D. If this guy has a value of 3, the orbital is F. So that is it. All right. So if you want to know how many types of orbitals that is present in a shell, azimuthal will help you. That is why if n is equals to 1, that is the first shell of an atom. N is equals to 1. Remember, azimuthal will start from 0 and ends at n minus 1. N in this case is 1. 1 minus 1 is equals to 0. So if n is equals to 0, azimuthal will only have a value of 0 because it's nothing like 0, 0. So if n is equals to 1, azimuthal will have just the value of 0. And if you could remember, now if you look at this table, if azimuthal is 0, with the orbital here is s. That is why you always have one s. You will never see one p. You will never see one d. You will never see one s equals to 1. Sorry, s. So you can only see one s in this life. One d, one f. I'll stop, teaching chemistry. All right. So let's move on. If n is equals to 2, L from azimuthal will start from 0 and ends at n minus 1. What is n minus 1? 2. 2 minus 1 is 1. So as this azimuthal. Now, according to this table that we have here, if L is equals to 0, the orbital here is S. If L is equals to 1, the orbital here is P. So if you combine this, it means that 2 can have 2S, 2 can have 2P. You will never see 2D. You will never see 2F. If n is equals to 3, if n is equals to 3, L will have a value of start from 0 and ends at n minus 1. What is n minus 1? N in this case is 3. 3 minus 1 is 2. So this will start at 0 and ends at 2. Now, what is the orbital for 0? S. What is that for P? 1. And this. So if you combine these letters with these 3, you have S, 3P, and 3D. That is why you will never have 3F. Please, if you have any questions, drop it on the box. Let me just wait for you guys. Please, if you're standing, drop a thumbs up. If you're following, please drop a thumbs up. Let me know how many of us are following. If you're following, just drop a thumbs up for me here. Thank you. Okay, someone said, I don't understand why it should be 3s and 3p, because if it is 3, if n is equal, if n is equals to 3, right? Now, the value for L is 0, 1, and 2, based on what I explained earlier. All right. Now, I told us that Azimuthal designated those numbers with a letter. Those letters is called orbitals. So for Azimuthal, anytime L is equals to 0, Azimuthal will call it S orbital. L is equals to 1, Azimuthal will call it P orbital. Anytime L is equals to 2, Azimuthal will call it D orbital. All right. So now looking at this, we have L equals to 0, L equals to 1, L equals to 2. So the orbital for 0 is S. Orbital for 1 is P. Orbital for 2 is D. It should, what this simply means is that for n equals to 3, for orbitals that these three can have is 3s, 3p, and 3d based on this. Yeah, that is it. All right, so I'm going to give us, okay, let me give us something to do. It's not just about moving on. Let's try something out. Please put down. All right, so I have a question here on the board which says, how many orbitals are present in n equals to 4 and n equals to 3? Do not forget that the n stands for shell. So when I say present in n equals to 4, it means shell equals to 4 and shell equals to 3. All right, so that's what it means. So I want us to try that question. How many orbitals are present or subshell are present? Now, without wasting so much time, let's solve this. I'll say solution. Please, anytime you're being asked for orbitals, your mind should quickly run to azimuthal. Azimuthal is the one that actually came up with a pattern that would help us to get the orbitals that are present in a shell. So if n is equals to 4, L would be 0, 1, 2, 3. Remember, L will always and ends at n minus 1. N in this case is 4. So you put 4 here, 4 minus 1 is 3. So this guy will start from 0 and ends at 3. Between 0 and 3, what do we have? 1, 2. So this becomes the value of L when n is equals to 4. All right? And do not forget that Azimuthal used a letter, an alphabet to designate these values. When L equals to 0, he called it S. When L equals to 1, he called it P. This is D, and this is F. So therefore, soft shell for 4, 4 is a shell. Shell number 4, right? We have S orbital, which is this guy. We have P orbital, which is this guy. We have D orbital, which is this guy. We have F orbital, which is this guy. Now, these are also called subshell. Why do we call them subshell? because they are all sub of shell number 4. All of them have 4 in it. All of them have 4, right? When something is sub, it simply means there is something that is actually holding them together. Sub means something below, all right? Something affiliated to something. So all of them has 4, 4, 4, and 4, right? So they are all derived from this 4 here. That is why we call them subshell. The orbitals present here are the s orbital, the p orbital, the d orbital, and the f. Please, if you understand what I just did here, please do the b part for me now. All right, I'm so much impressed. You guys are really doing well. That's correct. All right, let's solve the second guy. If n is equals to 3, L becomes 0, 1, and 2. And recall the letter used for to designate these numbers. This is S, this is P, and this is D. So therefore, shell number 3 will have subshell of 3S, 3P, and 3D. Please, these are the subshells. Why do we call them subshell? Because the shell is number 3. This 3 has S, P, and D. So the answer to this guy is this. So the 3 orbitals that are present here is S, P, and D. Now there is this particular shortcut I used to tell people. Imagine in exams you're being asked for how many orbitals that are present, right? If it was OBJ that is set A1, B2, 3, D4, basically just look at the number of this n. If n is equals to 4, that means it will have 4 orbitals. If n is equals to 3 and 3, just use that shortcut to be answering OBJ question just in case you see this kind of question in exams, right? They did not ask us to start explaining further. Imagine you saw a question, they said, how many orbitals are present in n equals to 4? A, 3, B, 4, C, 5. The answer is 4 because n is equal to 4. If you actually prove it, you see that it's going to give us 4. All right, so that is that for azimuthal. I believe you've learned something on the azimuthal. Let's go to magnetic. After magnetic, we do spin, and we'll end the class for today. All right, so let's look at Magnetic quantum number. Okay, somebody's asking me which topic. They are under, please, all these are under topic of quantum number. If you check through your past question, please, if you have not gotten your past question, try and get that from me tomorrow. If you check through your past question, you see quantum number appears so much. Tomorrow, I'll just be doing past question class. So based on what we've learned today, tomorrow I'll just gather past questions under quantum numbers, and we're going to be solving it together, right? So I will just solve maybe 1 or 2 years. You can now get the past question and solve the remaining years for yourself and boost your understanding. All right, please put down. Magnetic quantum number describes the orientation in space of an orbital. It describes the orientation in space of an orbital. That's number one. Number two, it tells us the number of subshell present in a shell. Okay, suborbitals present in an orbital. My phone, I don't know why. My phone is coming on. Now, okay, that's the difference between shell and orbital. So now look at it this way. Let me use an example. Shell is this. Now this is a nucleus. This is a shell. The small space where electrons are placed. These places. So these small places now is the shell. So it's more like a house that has a room inside. So shell is not same thing as orbitals. All right. Orbital is basically where electron resides. Orbital is where electron resides, a small space in a shell, a small space in a shell where electrons are residing, right? So take note of that. A small space where electron resides, that is an orbital. The shell is the body that is housing the orbital. All right, I think that's answered your question. You can use house for example. The house, your room, you sleep in your room, right? Room is actually the orbital, and your house is a shell. All right, so let's move on. Now, I said magnetic quantum number describes the orientation in space of an orbital. It also tells us the number of suborbitals present in an orbital. First, I'm going to explain that first one after the other. But let before I proceed, let me give us some few information you need to know. Note magnetic, which is Ml, which is L. What Once you know the value of L, you will know the value of Ml. Now let me show you something. We have these are the four quantum numbers: N, L, Ml, and Ms. L depends on N. Ml, L. Unfortunately, N and Ms does not depend on anybody. These two does not depend on anybody. Principal is independent, is the last one, is also independent of the others. The only two that are dependent is azimuthal and magnetic. And how are they dependent? Azimuthal depends on principal, because for you to get the value of L, you must know the value of N. If N is equals to 3, you can now get your L. So having established that, let's fire down. All right, so let's look at this. The next one is ML varies from minus L to 0 to plus L. Just relax, I'm going to explain it. Now, this is a formula. Please, MS stands for spin. It stands for spin quantum number. So you can either call it MS or you call it S. It's spin quantum number. Now, this is a formula for magnetic. That's the formula for magnetic. Someone is asking, is MS? MS, the last one is MS. That is spin quantum. So please pay attention. ML is magnetic, which is the one I'm trying to explain now. ML is magnetic. Now look at this. This is the first one is principal N. The second one is azimuthal L. The third one is magnetic ML, and the fourth one is spin MS. All right. All right. So we have minus L 0. This is a formula for magnetic, right? This is a formula for magnetic quantum. Let's see how we can use this formula very well. Class, let's see how we can use this formula very well. Is equals to 1. Now, what this thing is trying to tell us is that whatever the value of L is, ML is going to start from the negative of that value, goes to 0, and move away from 0 and get to the positive of it. So if L is equals to 1, the value of ML will start from -1, between -1 and 0, and then the positive of L is +1. Now, if L is equals to 2, ML would have -2, start from the negative of this guy, -1, 0, +1, +2. So that is it. You start from the negative of it, including all positive, all integers, right? From -2, before you get to 0, you will definitely see -1. So let me give us, if L is equals to 3, so you understand how we get the value of ML before I proceed. Please, can you, okay, if L is equals to 3, my ML will start from the negative of 3, which is -3, -2, -1, 0, +1, +2, +3. So that is how we got, or that is how this formula can be used, right? Just in case you're wondering, oh, how do we use this formula from -L to 0 and the rest of them? Very simple. That is how we can use that formula. So now, how do we apply this formula in solving problems? Remember, just like Azimuthal designated numbers with letters, those letters he called it orbitals. Magnetic also had a way of designating numbers with letters. Now let me show you something. Don't worry, it's getting interesting, right? Have you ever seen p orbital? Maybe in secondary school, you see p orbital have px, y, and pz. Please, you can comment on the section, on the comment section. Have you ever seen px, py, and pz like during your secondary school days? If you have seen it, please, if you have heard of something like px, py, and pz, please drop it on the comment section. Just tap, tap, tap. Let me be sure you're following. All right. The number 2 definition of magnetic quantum number is in an orbital. It tells us the number of suborbitals present. 2 definition of magnetic quantum numbers. All right. So now, P as an orbital. P has 3 suborbitals. That is a px, the py, and the pz. How did we know? It is the work of magnetic. I'm going to be showing us live and direct. So let's dive into it. Now let's say if L is equals to 1, that That's p orbital. Now our magnetic, which is our ml, will start from -1, 0, and +1. Now each of these can be seen as a box. Each of these can be seen as a box. So since it is P, now this is going to be, this guy designated this guy as Px, he designated this guy as Py, he designated this guy as Pz. Now this is actually based on the Cartesian coordinates. Now this is the y, this is the x, and this is z. That is a Py. If it is lying on the x, that's a Px. If it is lying on this, that's Pz. So that's how we got this. Remember, this guy, the first definition of magnetic is the orientation in space of an orbital. Right? The class is getting longer, and it's, if it is the longer, the boring. I don't know if you're understanding, but let me just wrap up. I'm going to drop a PDF material on this. So in case you understand this, the PDF material will help you clear your doubts. So once I end this class, I'll be dropping the PDF materials. Okay. So it's going to help us understand this part very well. I'm not going to be doing spin tonight because I don't want the class to be too long, right? So I'll do spin tomorrow, and then we solve past questions tomorrow. Jacinta, you said no. What? Why no? Okay. So therefore, it means that p orbital has 3 suborbital, because when L is equals to 1, ml becomes -1, 0, and +1. So this guy is a px, this guy is a py. This is 1, 2, and 3. So therefore, p orbital has 3. As simple as that. Remember, one of the application of magnetic is to tell us the types of the number of suborbitals that we have. So that is exactly how we got it. Now, how about if L is equals to 2? If L is equals to 2, how do we go about it? Let's clean this stuff. If L is equals to 2, that's the orbital. Who is this? All right, so let's do this. Our L will start from negative of these 2 to negative of 1, 0, +1. Now, each of these numbers stands for suborbitals. They have a value. Each of them have a value. So the box is 1, 2, 3, 4, 5, 5 boxes, which means L equals to 2, which is d orbital, has 5 suborbitals. Yeah, it has 5 suborbitals. Now, how do we designate this guy? This D, all of them will have D, right? They will have D. But remember, we call them suborbitals. That is why they are all having both all of them they have p's. So these px, py, and pz they are suborbitals of p. They are sub p's. So that is why we say p orbital has three suborbitals: the px, the py, and the pz. Now, so d orbital has five. How did we get to know? Based on this formula: minus l to 0 to plus l. So this is xy, xz, yz, z square. So once again, I'll drop a material for us to understand that part very well. Okay. If you have any question, that's good. If you have any question, please ask. By the way, please do this for me and drop it on my DM this night. Please, this night, do it and drop it on my DM this night. Do it and drop it on my DM this night. It's just a small example. Give the values of ml, give the values of, okay, let me use possible values so that it can give me everything. Okay, okay, just enter, no problem. No problem. Say, please, how will we know the letters to be used? Right? I'm going to share material so you can just look through that material, right? So you can understand better. Seems because I don't want the video to be longer again. And some persons are already sleeping. So I'll just end it. So I'll drop a material immediately after this class. I'll drop the chat on our group chat. Right. So if you're not on the group chat, if you're not on my group chat, my phone number is 070. Let me write it on the screen. 07038101576. So you can just write it down. After now, text me. So I'll add it to the group chats because we have a lot of things going on in the group chats. All right. Okay. Tomorrow is your orientation. We will not be having physical class tomorrow. Class resumes on Thursday. For those persons that may want a private class, private online class, right? In case you need a private online class, well, I'm seeing a lot of persons were texting me earlier today. In case you need a private online class, you can just chat me so we can discuss further. Okay. So please take down this question. Give the possible values of L and ML when n is equals to 3. Give the possible values of L and ML when n is equals to 3. Please attempt this question and drop it on my DM tonight. Tonight. I did not say tomorrow. Tonight. Marvel, don't worry. Like once I drop a material, remember all the videos, all the classes you're going to be having, I'm supposed to be dropping the material. So once I drop the material, if you read the material, you'll get it much better. Right? So with time, we're going to perfect the class. So we're going to perfect the class, right? So I can, time how I'll be, explaining stuff. So I don't want to explain further again so that it doesn't get to 11 o'clock, right? So please, I'll stop here. Immediately after this class, I'll drop a message on the group chat pertaining to the PDF material. So please go through it. And then if you have any question, my DM is always open 24 hours. Please make sure, try as much as you can to be attending physical tutorials as well. Right? We mean the very best for you guys. So please solve this, attempt it, attempt it. So I'm going to drop the material by 11:30. That's by then, most of you guys have attempted this question and sent it to my DM. Right? Once I drop the materials on the group, please, there will be no need you sending me the answers again because the answers most likely will be contained in the material as well. So guys, thank you so much for your time and audience today. I'll be stopping here for today. I'll drop my phone number. Let me drop my phone number. If you're not on the group chat, is that's my phone number. Text me so I can add you up. I've put my phone number. All right. Text me so I can add you guys up. So thank you so much for your time. Tomorrow we're going to spend 2 hours. Today I just wanted to welcome newcomers to our class. Attempt the question I sent to you, and after which I'll drop the PDF material. So do have a wonderful night rest and see you guys tomorrow. All right. You guys should take care of yourself. Bye.